Hello and welcome, everybody. As you might be aware, the Australian budget was announced 3 days ago, and the budget means different things for different people. So I created an application that lets you talk to the Australian budget. Let me just ask a quick question. What are the key highlights of the Australian budget 2025-26? And let's also enable text to audio, and let's select a voice, and let's submit question.
The key highlights of the Australian budget 2025-26, as outlined in the provided documents, include helping with the cost of living, tax cuts for every Australian taxpayer, energy bill relief, initiatives to provide more.
Now, this system that you just saw is called a RAG. RAG stands for Retrieval-Augmented Generation. So the user comes in and asks the question, what are the key highlights of the 2025-2026 Australian budget? The system knows to generate an answer, but how does it find the information, and how do we even know if what it has generated is correct? The answer lies in the references at the bottom. So first, before I get into the details of this, let me show you a simple example. Today, I open up Claude and I just ask, what are the highlights for the 2025-2026 Australian budget? Let's see what it responds. Okay. So it says, I apologize, but I cannot provide the details because it doesn't know. So the reason why that is because the model does not have information about the Australian budget because this was released 3 days ago. So now what if I gave it all the context? Now in this pasted query, I have added everything that the current system in the application would know. And now I paste it and I ask it the same question. And based on that, as you can see, Claude also knows how to find the answers and does give us a brief highlight of everything on the budget. So what really happened? What did I really paste into Claude that it was able to generate the answer for me? This is how it looks like. If I ask a question, what are the key highlights of the Australian budget? The source document is my budget overview. All I did was I uploaded this document to my application. And based on that, if I ask a question, it's really finding all the things that are related in the document, specifically to the highlights. So it says, okay, Building Australia Future, there's budget initiatives, there's budget at a glance, it finds different things. It also finds other stuff that's related to Medicare, clinic care. And based on that, it's able to generate the answer for me. So it's able to find all of this answer based on the context that has been provided to this document. So now that you have a taste of what this application looks like, I'm going to take you through every little detail and every little component of the Swag application. First, we will get started with what word embeddings are. Then we will look forward and understand how the system is able to find related words or related context based on the query that the user has provided. Finally, how does it generate an answer and how is it able to talk to us? So with that being said, let's get started. So as mentioned, let's get into word embeddings first. There is this amazing blog post by JLMR, a wonderful researcher who now works for Cohere. So previously in research, we used to have something called as word to vec. What it means is it's a converter that's converting a word to a vector. Now, these languages or these computers do not understand what words are. Like, for example, they don't know what king is. They don't know what man is. They don't know what woman is. These computers or the hardware that is powering the large language models only understand numbers. The word to vec is a technology that converts king, man, woman, or other words into numbers. So if I scroll down at the bottom of this blog post, this will show you that this king as a list or a vector of numbers. In this case, JLMR is showing us 50 numbers. And he's trying to show like how different words are similar to each other. So for example, if I put a color scheme to these numbers where minus 1.6 can be a blue and 1.6 can be a red. If I look at my screen, then king can be represented like that with that number. Man can be represented with that. Woman can be represented in this number. And you can look at how all the other words can be represented. Now, these 50 different dimensions are more like personalities. So these embeddings are basically representations, and 50 things you can think of like characteristics. Do they have long hair? That could be one of the dimensions. Do they talk softly or loudly? For example, could be another way of looking at this as a different dimension. Think of it like this 50 different dimensions of characteristics. And that's how words can be represented as numbers. Now, if I have to find something that's similar to queen, all I can do is I can take my 50 number string. So if I go back here, I can just take the string and I can find through something called as cosine similarity. It's just basically a way of trying to find the closest possible word or the closest possible distance to this string over here or to this array over here. And you can find the other words that are closest to this in the embedding space. So I hope that gives you a summary of what word embeddings or sentence embeddings look like and how we're able to find similar context or similar words, similar sentences based on for the user. So what happens afterwards is that when a user comes in, so I've created like a simple design to explain this RAG application to you. And after this, we'll be looking into the code base if you're interested. But overall, what happens is like a user comes in, they will ask a question based on this embedding search, like that whole query, for example, asking what are the key highlights of the Australian document will get converted into this embedding space. So there will be an embedding of typically it's 512, can be 1024, can be 2048, depending on how many characteristics or how many dimensions you want to extract. So the more dimensions you have, the harder or the more complex vocabularies you can represent in that embedding space. So for these models that are multilingual, you get a very massive embedding space. And what happens is then that sentence gets transferred into this embedding space. We do a cosine similarity, which is vector search, or can also be referred to as a vector search. There's other ways of doing similarity search. There's other ways of doing RAG. There's other ways of doing contextual chunking. There's parent-child chunking. I will not be going into the details of all of those techniques right now, but I will build upon this video in my future videos and in my future tutorials. So what happens is then you go into the database search. We are trying to find that context. We find these references that I just showed you. Remember how I put them in Claude? So you find them and you put that as context to RAG application, which then generates an answer. So the answer, because it already has now the pieces of information that you need to answer the question, it also has the query that the user is asking. It can really generate the answer for us. Finally, OpenAI has this amazing text-to-speech model called as GPT-4o Mini text-to-speech. You can read more about it at the URL provided below. But overall, that's how this application works. This is really a simple application that shows how I can take a user query, convert it into, get my Australian budget, and I can ask it questions and go back to the application. So let's try the application one more time. If I can say, what does the Australian budget mean for the Australian nurses? And ask the question again, so that you have an idea of what's happening as well. So if I look at the bottom, okay, this is what it's fine. Like for every taxpayer, this is what it's mean. This is what it means for every Australian taxpayer. It's again finding Australia's build the future of global economic environment. There's nothing specific about, I would say, about nurses in here in general, but because this context is not expanded, so there might be some sentences at the bottom of these contexts that it has found. And it gives me an answer, right? It says there's been an increase in award wages, so the budget allocates $2.6 billion. There's a workforce growth, but nothing really specific to healthcare. You can see like how the system is not really very specific. It's not giving me the best answers. And that's because it's a very simple system. We can do a lot more on this and we can really build on this system and we can make it like pinpoint accurate to the question that I ask you. And that is something that will happen in the future videos. But for now, I hope it gives you an overall summary of what this RAG application looks like. And I'm going to now take you through the code base that I had built to build the application. So now to take you through the application, actually, let me just take you through the backend. I won't be touching the front end, but if I take you through the backend, let me give you a bit of a surprise. Claude Code wrote all of this code for me. Like we had to make very little adjustments, but basically it was Claude Code. Not that I can't write code for myself, but I chose to try Claude Code. It's a way of experimenting the capabilities of this new model. But let me take you through the app on how it has built it for me. I had to tweak it a little bit. I had to tell it to do some things for me and do some things differently. But overall, it was able to do this really nice application for me in about roughly an hour of back and forth prompting and some code fixes that it took from my end. So the front end is built in Node. I won't be going into the front end now, but let me take you through the application's back end. And we will be building upon this back end. Like we will be using a better way of OCR. We'll be using a better way of processing the PDF documents. We'll be using a better way of we'll be using light LLM, or we'll go away from LangChain, how this has been built. But let me take you through the application now. So the first thing that happens is it's a fast API app. So a fast API app is really simple because once you have it's a fast API. So once you have a fast API, all you can do is you can add routers. So these routers are where they become like endpoint. So when your front end, if you click a button, you can really trigger an endpoint. So when I click query, this query will be clicked and will say received query. Like this is where the endpoint will go. And you can say it's doing like a RAG engine.query. So RAG engine is where all of the smarts are happening. So if I go on the RAG engine, actually, this is what the main brain of all of this RAG system pipeline is. And it does not have any evals. It does not have there's a lot of things we can do to this, but I've kept it simple. Let's look at the initialization of this. So the first thing it's doing is it's getting my OpenAI API key, or, if it doesn't exist, actually, let me show you this one. It says I'm using Hugging Face embedding. So then it's creating a Hugging Face embeddings model, and it's using sentence transformers. So remember how I told you every sentence could be converted into this embedding space? Initially it would start with the OpenAI embeddings, which is provided by LangChain. Again, this is something that I'll just add a to-do, update this to use contextual embeddings from Anthropic. So that's one thing we could do. Another thing we could do is we could use Ollama here, or we could try to use Llama 3.2, 1 billion. And one thing that it's really missing is keyword search. So maybe let's also add that over here. So I'll just add add keyword search, for example, BM25. So now those are three big things that we can directly make updates to my code base. But overall, if you see it's creating an embedding model. Going from the embedding model, it's initializing my LLM. So that's just, again, using chat. That's using using LangChain. So chat OpenAI is just a very simple query model. Then it's creating Chroma DB. I don't really firmly believe that we needed a Chroma DB here, because it's a very small vector database. We could have just done NumPy arrays, but that's okay. It's created a Chroma DB for me. And then it says, okay, if the path exists, that's my vector store, because in the vector store, it provides an embedding function. So this embedding function is the self.embeddings, which is the OpenAI embeddings. So that's where it's creating the Chroma database for me. Next, it's using a recursive text splitter. Now, I don't like this personally. To do remove recursive text splitter and use contextual chunking or other strategy. What this means is there's the recursive character text splitter. The way it works is if you have a sentence that looks like, hey, I am Aman. I am currently working on a RAG pipeline, or should I say a basic RAG pipeline that uses recursive text splitter. Now, I think the way this LangChain text splitter works is it will split it. If I've set it to 50 characters, and that's the 50 characters, then this becomes my second chunk, and the top, this becomes my first chunk. So as you can see, if this is my chunk 1, this is my chunk 2, and then this will become my chunk 3 going by the logic. So as you can see, what happens is it's really splitting my sentence without even thinking of what context there is. If I provided a first chunk to my retriever, it will not be able to give me a good output, because it needs to know the whole sentence to be able to produce good outputs. So that's one of the key things that we can help improve here as well. This prompt template is really just a system prompt, or just prompting. Actually, this goes as a user prompt. It's just saying you're an expert assistant that helps with understand Australian budget documents. Here is the context. So this context is coming from the retriever itself. Here is the question. And now you say answer, blah, blah, blah. And you do this because you're trying to conditional generation. So you're conditioning your output basically to start with the answer. So there's a space, and now the only thing that's left for the model to do is to generate the answer as a whole. You create all of this as an LLM chain, and that's pretty much it. This process and index PDF, so initially in our database, when we have to create the database, this is when you upload the PDF, it's using PyPDF loader. Now again, try Mistral OCR here, or Llama Index. So those are the two most famous industry ones for PDF processing, and we can try them both here. I think that will really improve the performance. That's basically that. Because so what happens is if you upload a PDF, there's images, there's charts, there's a lot of stuff. And this will not really give me good outputs, because it will not be able to extract the information from the PDF in the way I want it. Now this split documents, again, this is just coming from the character splitter. It's adding some sort of metadata. So we can do metadata filtering sources in the future, like what source it's coming from. We saw it in the references. It knew what page number it is coming from. And that's pretty much it. Now query is where when I click submit my question, query is where it is going in the backend. And if I go in here, you can see how it's doing like a vector search similarity search. So this is something that also can we build upon this similarity search? And is there another method that works better for me? Now that's something we can try. Oh, let me just add a to-do here as well. But it's doing the similarity search. So you get a query, it converts it into a vector embedding, and then it's trying to find similar context or similar chunks. And then finally, in the end, it's like trying to get your metadata. It's adding it to the context. All of that context gets appended as full context. Now see how it's passing that as full context to the context. So the query and the context are going together, and that will fill my prompt template over here. So all of that context goes in, the query goes at the bottom, and finally you have an answer. So you see how simple this is? Like we have not added any research into this. We're not even trying Colbert, which is so actually that should be something else to do as well, to do add Colbert. And there's like a lot of things that I'm missing, but overall, I hope that this application gives you an idea of how simple and basic RAG works. So I really hope you like this video. In the future, like we're only going to build on top of this. We're going to add new research. We're going to add new methods of text extraction, basically PDF extraction. We're going to look into converting this into something called as agentic RAG. So we're going to add tool calling. We're going to try something called as case-augmented RAG, which is called CAG. And we're going to build evals into the system. So we're really going to go in and hone into RAG and really understand everything that there is to know about the system. And we're going to try it with various different documents and see how the end result looked like in the coming few weeks. Do hit the like, share, or subscribe button. It will really motivate me to create more and more such videos for you. So thank you for watching.